This video will review over percent yield problems and mass problems. When you perform a laboratory experiment, the amount of the product collected in the lab is the actual yield. Before going into the lab, the amount of product calculated from the limiting reactant will be the theoretical yield, or the maximum amount of the product that can be produced under perfect conditions. The percent yield is the amount of the actual yield compared to the theoretical yield. The better the lab is performed, the higher the percent yield. No percent yield can go above 100, and rarely with rounding will a percent yield approach 100%. So let's look at a few percent yield problems. Suppose a student performed a reaction and obtained 0.875 grams of copper carbonate, and the theoretical yield is 0.98 grams. What is the percent yield? Well, in these problems, what we have is we have a very simple equation where we have the actual divided by theoretical times 100 to equal the percent yield. So what we need to do is let's look and identify each of these components. So we had 0.875 grams obtained. This right here is our actual, and we'll go right here in our equation. The theoretical yield is 0.98. It will go right here. We multiply it times 100, and we get 88.6% yield. However, many example problems will not give the percent yield. They will give you a balanced chemical equation. They will give you the chemical that you're starting with, and they'll give you an actual amount. So let's look at the example and see how we would approach these problems. First off, we have a balanced equation. We have 36.8 grams of C6H6 reacting with excess Cl2. That means we can ignore the Cl2. The actual yield is 38.8. What is the percent yield of C6H5Cl? The first thing we need to do is to identify the actual yield. Now this will go in our equation, actual divided by theoretical times 100. However, our theoretical yield has not been calculated. To do that, we must do a mass problem to get the theoretical yield. Here we have our equation for our mass problem. In this example, we have 36.8 grams of C6H6 that will be identified as chemical A, and we have 38.8 grams of C6H5Cl as our actual that we'll set aside, and so C6H5Cl will be chemical B. Do note that there was an error in this, and as we look at this equation right here, 1 mole of A should be on top and weight of A from the periodic table should be on bottom. Now that we have identified chemical A and chemical B, we will plug our formula, our numbers into our equation. 36.8 grams of C6H6 given in our problem. We have our 1 mole of C6H6 over 78 grams. This is the weight from the periodic table. We have our coefficients from our balanced equations. We have 1 mole, the weight from the periodic table. We get our theoretical yield as 53.2. Our actual yield is 38.8. Now I did notice on this equation that we do need to fix it, and this needs to be switched. Now that we have our actual yield of 38.8 and we have our theoretical yield of 53.2, we plug those into our equation. multiply times 100, and we get 72.9%. I do want to clarify that the previous slide did have one section on the equation backwards. So just as a reminder, mass is given mass of A times 1 mole of chemical A over the weight of chemical A from the periodic table times the coefficients of A and B from the balanced equation times 1 mole of B, weight B, from the periodic table, and that will give the mass of chemical B. The previous slide had this section right there backwards, so do make sure that you fix that.